Hi, this is Mrs. Sigala, and this is your homework for section 4.10, writing chemical formulas with ionic compounds, but these will include polyatomic ions. And so I've gone ahead and included your periodic table of elements here, your polyatomic ions, which are right over here, and also your prefixes for your covalent compounds. All right, now, first, I like to go over, kind of separating all of our compounds into groups, and that way your mindset stays on one group at a time. You're not shifting from an ionic compound to a binary acid to a covalent compound to a ternary acid. So let's identify what's easiest for us first. And you can start wherever you like. Now, a lot of my students say, oh, we can identify acids right away. Again, because you're going to end with the word acid. So I'm going to go ahead and start with those. So here's acid, 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 and it looks like that's it. Okay. Next, I like to separate my acids into two. I like to separate them into binary or ternary. And again, this is sulfurous, so this would be a ternary because it's not starting with hydro. This is OUS, again, it's ternary because it's lacking hydro. And our last acid begins with hydro, so we know it's going to be binary. Okay. All right, so next, my students like to identify covalent compounds because they have prefixes, so those are easy for them. So we have penta, so this is covalent. We have, let's see, penta and di, so this is covalent. Keep looking. And that's it for covalent compounds, okay? All right, so next, my students, next it gets a little tougher, okay? Because next we're looking for ionic compounds, and ionic compounds will have some, a metal and a nonmetal. We're talking specifically about groups 1 and 2, and also we're talking about specifically group 13, or basically everything to the left of the zigzag line. Okay, so I'm going to go ahead and draw that zigzag line in a different color so it's a little bit more obvious to us. And again, ionic compounds will have will be composed of a metal and a non-metal, which is to the right of the zigzag line. Okay. All right. So, and this is a little where it gets a little bit tough. Now, if we go back to ionic rules, we remember that the very first name will always be the full name of your metal. Then the second part will be your non-metal, but that non-metal will always, it'll have the root or stem of that element, and it'll end with IDE. So you only have to be careful for a few polyatomic ions that end in IDE. The first one will be cyanide, hydroxide, and I believe that's it, okay? Everything else will end in H or ite, with the exception of ammonium, which will end with UM. Okay, so that's probably one of the easiest ways for me to identify the difference between ionic and polyatomic. And so in this case, I look for sodium fluoride. Fluoride is not a polyatomic ion, and so right away I identify it as ionic. Okay, perchlorate, nope, that's definitely polyatomic. Hydroxide's polyatomic. Okay, nitride, here we go. Sulfide, ionic. And it looks like that's it, okay? So that basically makes everything else polyatomic. I'm going to use the color blue for this one. So it's polyatomic. And again, I might make a mistake while I'm doing this, but as soon as I go over my rules and I follow my steps, I'll be able to find my mistake if I do identify something incorrectly, okay? So again, I like to go in order, okay, with what's easiest for us. Okay, let's start with covalent compounds today. Okay, again, covalent compounds, this is the only time we're not going to be using the crisscross method. So use your prefixes. Nitrogen penta, again, penta means 5. So we have, there's no prefix in front of nitrogen, so it's automatically 1. And we have fluorine as a root word, and we're going to have 5 of those fluorines. Next, we have disulfur. Di means 2. And then my root word is oxygen. and we're going to have 5 of those oxygens. Okay, next I'm going to go to my acids. Okay, and again, remember binary. Do we have any binary? Yes, we do have a binary acid down here. A binary acid will always start with hydro. And again, all acids begin with the element hydrogen. And iodic, this is iodine. So again, in this case, I start to use my charges. Hydrogen is +1. Iodine, again, is found in group 17, and it has an oxidation of -1. And I'm going to go back to that. So I'm going to crisscross, and I'm going to end up with H1I1. But again, I don't have to include those ones because if we don't include them, it's automatically assumed that it's just one of each. Now, one thing I forgot to do was go to my periodic table and write those oxidation numbers. So I'm going to go ahead and take care of that right now. Okay, so again, group 1 will always be +1, +2, +3. It's going to be plus or -4, or it can be +2. Then we go in reverse, -3, -2, -1. Group 18 is 0. Okay, and that's just something you have to memorize for now. We'll be covering the periodic table next semester. All right, so back to my acids. Okay, now I have a ternary acid, and again, here's sulfurous acid. It ends with OUS. So I'm going to go back to ites. So this should be sulfites. So I'm going to look for sulfites on my polyatomic ion sheet. It's right here. So it's SO3 with a charge of -2. So again, all acids start with hydrogen. Okay, I'm going to put this in parentheses, and it has a -2, and hydrogen is +1. And I'm running out of space here. That's the only reason I am writing it to the side. So again, this +1 goes in front of my parentheses, behind my parentheses, sorry, and this 2 will go in front of my hydrogen, so my answer is H2SO3. Okay, next one, I have nitrous acid, so again, that would come from nitrite. Nitrite, it's right over here, it's NO2 with a charge of -1. So I'm going to write down my hydrogen, and this I'm going to write my charge down. Nitrite is NO2, and the charge is -1. I'm going to crisscross these charges, and my answer is HNO2. Alright, and that's pretty much about it for my acids. Next we come to polyatomic ions, and again, we're looking at, do not think that you remember these polyatomic ions, just look at your list. I still have to look at my list just to be on the safe side. Okay, so polyatomic ions will always begin with a metal, or don't forget, we can also have two polyatomic ions that are attracted to each other. So in this case, we have potassium, and that symbol is K. Potassium is in group 1, so it has a charge of +1. Permanganate, where is permanganate? It's right here. MnO4 with a charge of -1. So I'm going to put this in parentheses. MnO4, charge of -1. I'm going to crisscross these charges, so my formula stays as K MnO4. Nothing changes because, again, they're ones, so we don't have to add any subscripts. Since we only have one polyatomic ion of permanganate, we don't need parentheses. Next, we have calcium, which is in group 2, so it has a charge of 2. And we have hydroxide, and hydroxide has a charge of -1. I'm going to crisscross these. So it is going to be Ca, parentheses, OH, 2. Make sure you write those parentheses in there if you have more than one polyatomic ion. Okay, next we have sodium perchlorate. So again, sodium is Na. It's found in group 1, so it has a charge of +1. Perchlorate, here's perchlorate, ClO4 with a charge of -1. I'm going to cross these. I don't have to change anything, so my formula stays as Na, ClO4. Next, I have ammonium hydroxide. Okay, so again, I'm dealing with two polyatomic ions, so I'm going to write down my parentheses. Ammonium has a charge of +1. hydroxide has a charge of -1. So this one comes in front of my parentheses, this one goes behind my parentheses. So my formula stays as NH4OH. Next we have calcium carbonate. Calcium is found in group 2, so it has an oxidation charge of +2. Carbonate, here's carbonate, CO3 with a charge of -2. Okay, I'm going to crisscross, but I noticed right away also that I can simplify this by 2. So my formula stays as CaCO3. Next I have calcium chlorate. So again, calcium is in group 2. Chlorates, let me look for chlorate. ClO3, charge of -1. I'm going to crisscross them. So I have 1 calcium, but I'm going to end up with 2 of these chlorates, ClO3. So I'm going to use parentheses. I'm going to put that 2 behind that parentheses. Next I have ammonium sulfates. Ammonium has a charge of +1. Sulfates, what do we here? SO4 has a charge of -2. Again, we're going to crisscross these. I'm going to end up with, again, parentheses, NH4. And parentheses are required because you have more than one ammonium polyatomic ion. But behind that, it's not required because we only have 1 sulfate polyatomic ion. Okay, next we have sodium sulfite. So again, sodium is Na, charge of +1. Sulfite, SO3 with a charge of -2. I'm going to crisscross. I'm going to end up with Na2, SO3. Okay, ammonium chromate. Here's ammonium, +1. If I look for chromates, here's chromate, CrO4 with the charge of -2. Okay, make sure that you're looking for the right one, okay, because sometimes it's dichromate, sometimes it's chromate. So here I'm going to crisscross. So my formula will be NH4. I'm going to try to squeeze this in. We have 2 of those, CrO4. Okay. All right, our last polyatomic ion, we have potassium chromate. Okay, with the charge of +1 because it's in group 1. We just finished using chromates, CrO4. Make sure we're down. Yep, CrO4. And it has a charge of -2. Again, this 2 comes in front of my K. My 1 goes behind my parentheses. So my symbol is K2, CrO4. All right, next I forgot to do my ionic compounds. So I'm going to go ahead and do those. Okay. So here I have sodium and fluorine. So again, sodium has a charge of +1. Fluorine's in group 17, so it has a charge of -1. I'm going to crisscross these ones. I don't have to rewrite them, so my formula is simply NaF. Have lithium nitride. Lithium's in group 1, +1. Nitrogen is in group 15, so it has a charge of -3. I'm going to cross these. My formula is Li3N. And my last problem is barium sulfide. Again, here's Ba. Ba is found in group 2, so it has an oxidation number of +2. And then I have sulfide, or sulfur in this case, which has an oxidation charge of -2. I'm going to crisscross these. End up with Ba2S2. But I can simplify and reduce these, so my final formula will be Ba2